So Harinder Seera was a part of our previous virtual pack, the Jurassic Pack, and he's based in Melbourne. He's also been involved in several pack meetup as well. He is on the Blockchain Advisory Board of Global Skill Development Council. He has also authored an ebook called Introducing to Blockchain. So Harinder has expertise, obviously, in the performance engineering and blockchain landscape. So it's great to have Harinder. He made an awesome topic during the Jurassic Pack. For those who didn't have the chance to be connected for a Jurassic Pack, you can still watch Harinder's session, which is available in the archives of our websites or on YouTube as well. So today, Harinder is going to talk about one of the technology that is available in Amazon, so AWS, called DynamoDB. So it's a NoSQL database. So there are a couple of advantages, of course, of using DynamoDB, but you have to configure it properly to take advantage of it. And also, there are a few things to consider, especially depending on what you're going to do in terms of implementations, and to avoid any surprises in terms of costs or anything like this. All right, so I'll let you present, and we see you in 30 minutes.
Awesome. All right. Thanks, Henrik. And thanks, Neotys, for giving me this opportunity again to come and present at PAC. My topic for the presentation is DynamoDB Be the Name. That's a play on word for one of my favorite rock bands that I listen to. And if you can tell me the band's name, so I've got the mouse code for that band next to my title, you get a brownie pounds from me. So let's get into the pack. So the playlist, the topics I'll be covering, I'll basically go a little bit about what DynamoDB is, just an introduction to it. I'll talk about partitions, and then we'll get into the lessons learned while implementing DynamoDB. And finally, cost optimization tips, things that you can do to optimize DynamoDB cost. So further ado, all right. So I'm going to be a little bit fast because I've got a lot of things to cover, but I'm happy to answer your questions after my presentation. So what is DynamoDB? It's basically a fully managed proprietary NoSQL database service provided by Amazon that supports key value and documents data structures. When you talk about DynamoDB performance, it basically starts and ends with the concept of partitions. Not understanding partitions means you're not going to design a really highly effective and available databases with DynamoDB. So it's a critical concept that you need to understand. Behind the scene, partitions are just a unit of storage backed by SSD. Now, like your normal databases, you've got rows and tables. DynamoDB doesn't follow that concept. So it's just the records that you're adding into DynamoDB. And they call it item. And these items are stored in partitions. So on the right-hand side, the topmost diagram you can see or image, you've got a record with product ID 3. So that whole row is an item. Now, the way DynamoDB stores the items is using primary key. And part of the primary key, either it can be a partition key or a composite key. And partition key is the one that decides which partition that item needs to go into. Also, another thing is you want to make sure you select a partition key which has a high cardinality attribute. Choosing a wrong partition key can have a huge performance impact, especially you might end up finding hot partition key issue. So that's one of the other critical things to know when you're designing the DynamoDB structure, that make sure your partition key is highly cardinality for this partition key is really, really high. Also, finally, the DynamoDB itself is optimized for uniform distribution. That's another thing to be wary of. If you got a highly cardinality attribute, chances are you will get a at least close to 100% uniform distribution for your items, which can be basically saved or accessed from the partitions. Next bit is how does DynamoDB internally adds the item or accesses the item from the partition. So what it does is it uses a hash key function. So you pass in the partition key, in this case it would be your primary key, into the hash function. It generates a value, and that value is basically mapped to your partition. So it will write the record into that partition or read from that partition. Another thing you need to be wary of, there is some restrictions for these partitions. You can have a maximum of 10 gigabyte of data in one partition. So if you cross above 10 GB, internally DynamoDB will create a new partition. Next bit is there's a limitation of how many read capacity units you can, each partition can handle. Same thing with write capacity units. There's maximum of 3,000 read capacity units. So when I say 3,000 read capacity unit, it's mainly for your provision capacity. On demand doesn't have, it does have a restriction as to how many read request unit you can do, not the read capacity unit, it's more read request unit. And for the write is 1,000. Next thing you need to be wary of when you're designing your DynamoDB tables is what kind of read consistency you want. So there are two types of read consistency. One is your strongly consistent read. So when you're querying the DynamoDB, if you want to get most up-to-date data, you basically select strongly consistent read. If you are happy for a small delay, you're happy with the stale data as it doesn't impact you much, you can go with eventual consistent. For example, Twitter feed. Even if there's a delay of 1 second for Twitter feed, it's not going to impact your application. It's not a critical thing if there is a delay. Whereas if you're looking at stock trading, a 1 millisecond or 2 millisecond of delay can have a huge impact on the trading. So that's where you have to select what kind of consistent read do you want to do. Also, another thing that you need to be wary of is when you talk about provision capacity for DynamoDB and on demand, what does those unit like read capacity unit mean or write capacity unit mean? When I say for provision capacity, a read capacity unit for a strongly consistent means if you have one read capacity unit equals to one strongly consistent read per second. If you're doing eventually consistent read and you have provision capacity, you can get 2 eventually consistent reads per second. This information is really, really critical when you're looking at the cost optimization because it can impact how much you're paying for DynamoDB usage. And if you're doing a transactional read or write, they're even more expensive. So basically you need 2 read capacity unit for 1 transactional read per second for provision capacity. And similarly, if you're doing, if you're on demand, you're paying 2 read request unit equals to 1 transactional read. Same thing goes with the write capacity unit and write request unit. They are a bit confusing, those terms. I wish Amazon had a different names for them rather than RCU and RRU kind of thing. So that's a bit of a background about DynamoDB. Now we'll get into the performance issues or the issues we encountered when we were implementing DynamoDB. The first one is hot partitions. This is a quite famous issue or well-known issue around DynamoDB. So if you Googled for performance issues, Hot Partitions would probably be the top of the list in the searches. So what exactly is Hot Partition? Remember I mentioned that DynamoDB is optimized for uniform distribution. Chances are when you're designing, most of the cases, you're not going to have a uniform distribution. So there are partitions that might receive more requests, read or write, than rest of the partition. And with that limitation that I was mentioning earlier, 10 GB and 3000 read and 1000 write, they come into play. And you might hit a limit at the partition level where you're trying to request more items and you're reaching that limit, and therefore DynamoDB is throttling your request. And that's what Hot Partition is. In our case, we had a base table and we created a secondary index, or you can call it global secondary index. Example, like in normal databases, we've got indexes to improve our performance, to get results quickly. There's a similar thing you can do with DynamoDB. You can implement local secondary indexes or global secondary indexes. In our case, we had implemented a global secondary index, whose partition key was a sort key. So remember I mentioned that you have to have a high cardinality key for the partition key. In our case, for global secondary index, the cardinality was not high, so we were using a sort key as a partition key. And the sort key number, you could only have 5 sort key numbers, 1, 2, 3, 4, and 5, which means in the background you had 5 partitions. So I'm basically, in reality it would be more, but I'm just, for example's sake, saying we had 5 sort key types, and let's say 5 partitions were created. So chances of each request hitting any of those sort keys was really, really high. So what was happening was, as we were writing the requests to the base table, it was also writing and updating the global secondary index. And because our primary key for global secondary index was a sort key, which wasn't unique enough, it was throttling at the global secondary index level, and then putting a back pressure on our base table, which would then throttle all the requests that we were writing. So we were doing an ETL job, so we were loading roughly 50 million records from one system into this table. With this issue, it took us around 7 hours to load the whole data because of the throttling issue. After we fixed our change the partition key for the global secondary index, the same ETL job was taking 30 minutes. So that's a huge improvement in terms of selecting the right keys for DynamoDB table. The right-hand side, you can see those graphs. That's my testing that I was running. So you can see I provisioned 21,000 write capacity unit, and I was hardly hitting 5,000 consumed units. And next to it, you've got throttle write events that were happening. So our base table was throttling those requests and then having a back pressure on our base table. The bottom heat map is when I encountered this issue, I reached out to AWS saying, I'm having this issue. Could you help me understand what's going on? So at that point in time, they had their own internal tools that can generate a heat map to show you which partition is getting more load. In our case, we had total 32 partitions, and only 2 partitions, which is what the heat map at the bottom is showing, were getting most requests, and they were getting rejected. So that's a useful, handy heat map to have if you got any throttling issues. Now, AWS recently, I think it was end of last year, they have created a new capability that you can now analyze that throttling issue using CloudWatch Contributor Insights. So if you've got DynamoDB, if you go to DynamoDB console, there's an option to enable CloudWatch Contributor Insights. Once you enable it, and if you're running production load or you're testing it, you can see which partition, how many requests they're receiving. Also, I have created a GitHub, I've created a Python code to help me with my performance testing. So as part of our pipeline, you can basically implement this code, which goes and enables the CloudWatch contributor insights. So it enables it, so you can start seeing the metrics, which you can then write it to a different database, time series database, to get that information. After the test is run, you can execute the script again to disable the contributor insight. It does cost contributor insight, so that's why you want to make sure you enable it, capture what you want, and then disable it. So that was one of the issues we encountered when we were implementing DynamoDB, and the way we resolved is to make sure our partition key for global secondary index was unique, had a high cardinality, and that solved our issue. Next issue, that's not an issue kind of thing because the dev guys did a really good job. Basically, you've got two different operations that you can perform on read request. One is you can query, another one is you can scan. Now, it's similar to databases where you can query and scan, and most of performance engineers and DBAs will say, don't do the scan, don't run scan on your database. It is slow. That's the thing with DynamoDB as well. When you run scan, you're scanning the whole table. So imagine that 50 million records we've got in a DynamoDB, running a scan on it. That will be really, really slow to get an item. Instead, use query. The query, you pass in the primary key to the query code, and what it does is it navigates through just that partition where that primary key is. So it doesn't go and scan the rest of the partitions. Just on that primary key partition, it will go and look up the value and return the data. Now, you can use sort key with the primary key to improve the query performance. So basically, it will just go, it further refines your request. If in terms of scan, as I mentioned, it will scan the whole table, which means it will consume more capacity. Also, both query and scan, if they're returning more than 1 megabyte of data, the response will have an attribute key called last evaluated key, which tells you, hey, there is more data still. So you need to use that key to make subsequent requests to get more data. So be wary of that if you've got more than 1 megabyte of data, that means there's a lot of, it's a big response that you're trying to get. If for whatever reason you want to scan, I wouldn't recommend scanning, but if for whatever reason you want to scan, use parallel scan instead. So what it does is you specify segments of partition, so it will, and threads, so it will basically run that many threads and try to scan in segments, which will improve the scan performance. That's like your last resort if you want to scan. But it also will consume more provision capacity. Now, if you've got other applications that are also accessing DynamoDB and you're running a scan, parallel scan, you can then end up having the hot partition issue because scan will consume more capacity and other application might be also using capacity, your read or write capacity, so you could potentially end up hitting the throttling issue. So you need to be wary, you need to make sure you've got the right segment sizes that you're trying to scan and work with what's going on in your application. Knowing the application, how it works, will be useful for you designing the right settings for parallel scan. Next bit is use projection expressions or filter expressions when you're making a query call or even scan call. So what projection calls does is it will first get the data and then it will look at projection expressions as to what data I need to now send back to the application. For example, let's say you have an item which has a first name, last name, address attributes. Now you can say in the projection expression, just give me the last name. So DynamoDB will make a call. It will get a whole item information, first name, last name, and address, and then it will apply the projection expression on top, and it will only send you the first name. Now, by doing that, you're basically avoiding unnecessary network bandwidth consumption. So if you only need one or two attributes, use projection expression. Another one is filter expression. Now you can do filtering. You can say, hey, all I want is all the students who have gotten more than 70% on their physics test. So you're basically applying filtering on top of your result. So it only sends the amount of data that matches that criteria. Again, it saves your response size and your network bandwidth consumption. On the right-hand side, you'll notice I've got two different graphs. So one is I was experimenting on the side because we don't run scan in production or in our test environment. I wanted to see how long does a scan take if I've got 1,000 items in my table. Each one is less than 4 kilobytes. What kind of response time I'm getting? You can see the scan. This is just 1,000 items in the table. Now imagine if you had millions of them. With 1,000 items, I was getting a large distribution variance in my scan response time. It was varying from 0.35, 30 millisecond, all the way to 150 millisecond. Whereas your query, it was all between 25 millisecond to 50 millisecond response time. Now, this testing that I did was I was connecting my test machine over a Wi-Fi connecting to DynamoDB. So this latency includes my connection time and all the end user time as well in there. So, and the bottom graph is our production query latency. That's in milliseconds, and in last 24 hours, you can see roughly 3 milliseconds we are getting for the query calls. That's for the query and scan. So yeah, so if you want to use any operation to read data, use query. There are other operations which I'll talk next, but query is more performant than scan. And next, we'll move to get item API versus get batch get item. Again, confusing names. So these are other two APIs that you can use to read items from the DynamoDB table. So get item basically reads a single item from a table, and it's quite efficient to read single item because it provides a direct access to the physical location of the item. So some might wonder what's the difference between get item and query. So get item is equal to query when query has a limit of 1. So when query has a limit of 1, you'll get roughly the same response time as get item. You can see from my graph on the right-hand side, the get item response time matches pretty much same as what I was getting with the query response time in my other graph, the previous one. Also, you've got an option of using batch get item. This one returns 100 items, and you can basically access multiple tables. So you can make this call. You can have saying, okay, I've got 6 different student IDs that I want to get a result from in one table, or let's say you're just storing the results. In other table, you're storing the address details. So you can say, I need for these 10 student IDs, get me the result as well the addresses. You probably want to use batch get item because one, it is faster because it fetches the item in parallel, which minimizes your response latency compared to get item. So if I had to get 10 items using get item, I had to make 10 different calls, which means you making the connection, getting a response, then making another connection, getting a response. whereas batch get item reduces that. It fetches that in parallel, and you get the response. Next bit is, this is again related to network utilization. You've got 1 megabyte limit on the data that get item will return, and 16 megabyte of data batch get item will return. Now, in case you've got more than 1 megabyte or 16 megabyte of data, you'll get a attribute called unprocessed key in your response, which tells, hey, there's more data still to you need to get, so you'll need to make a call. Right? Now, you can apply filters, again, projection filter expression on these APIs, which means you can reduce the amount of data you're sending over the wire or the network. That will help with the performance. Again, if you're going across different regions, that will save you in terms of cost. So I've got those two graphs. Again, I did some experiment to compare get item API versus batch get item. I was getting roughly the same response times. And the bottom one is our production latency graphs for both. And you can see batch get item, even though we've got like millions of records, the API response time, it's consistent to what we're getting with get the item latency. So it's almost same for both of them. So those are the issues we encountered when we were setting up, or things that we implemented when we were setting up DynamoDB. Next, I will basically talk on the cost optimization tips. What are things you can do to optimize DynamoDB cost? First one is a usage pattern. This is quite common. You will read this on the different posts. They talk about the usage pattern. If you're not sure how anyone or how system will be, how your DynamoDB table will be used, or how they'll be accessed, use on-demand capacity. Basically, you only pay for what you use. So it's in that sense, it's good, because if you're not using at nighttime, you're not paying for it. However, if you have a predictable pattern, but it's variable, like in our case, we have got ETL jobs that run in production at specific time of day, and then we've got our normal traffic. So it's a bit variable, but we know it's predictable when we will be running ETL. We do the provisioning, so we use provision capacity. That saves us quite a bit of cost over there. If in case you have a predictable and steady pattern, so let's say you'll always get 1 TPS, that's the 1 request per second, always, then go with the reserve capacity. You will save quite a lot of money on reserve capacity. In our case, we use on-demand and provision capacity, depending on the workload that we are running in production. As you can see on the right-hand side, the graph, that's a production graph. We were running an ETL job, so we pre-provisioned the capacity we needed to use. And then the blue one is our consumed capacity. So once we finished our ETL job, we brought it down to on-demand. Next cost optimization tip is implement time to live for your items. There are situations where you have a data that's temporary, you won't need it after a while. For example, session information. Once the session is over, you'll probably clear out the session details. Or if you've got event logs, or let's say you've got like Black Friday or different sale days, after those sales are over, you probably revert back to the old price. So those kind of things, you can have a time to live attribute in DynamoDB. So what it will do is when that time to live value is breached, it will delete that record from the table. Next tip is minimizing number of indexes. As I mentioned earlier, we had a global secondary index on one of our base table. Now, global secondary index, they've got their own read and write capacity, and they also have got their own storage capacity. Storage, not capacity, but their own storage. Now, if you got multiple indexes on your base table, all those indexes will have their own storage. Now, if you make an update on the base table, and it also needs to update all the indexes, it is first going to consume all those capacities, and also it will be consuming the storage. So you're basically incurring quite a lot of cost over there. So one of the things you want to do is, if you're not using a query, delete that query, or basically have attributes in the index that are only what's needed. So which is my point number 2. Only project attributes that are required. Avoid selecting all. Instead, use include where appropriate. So you can say, all right, for this index, all I want is the first name and last name. Just include those attributes. Don't include address, don't include age, don't include their date of birth if it's not required. They will consume space storage. That's another tip of how you can reduce cost. Fourth one is use expressions, which I've mentioned earlier. You won't avoid the capacity unit cost, but what you'll avoid is sending unnecessary data over the network. It will help with the performance because you're not sending a 1 megabyte of data. Instead, you might be only sending 300 kilobytes of data. If you're moving the data across regions or outside one region to internet, you're basically paying for that data. So hence why, where appropriate, use expressions to send less data. Fifth point is capacity target utilization. That's another tip that you can implement. So basically, if you go provision capacity, by default, there's a value called capacity target utilization, and its value is 70%. So what DynamoDB tries to do is it tries to use only 70%. So if you're going above 70%, it will pre-provision the capacity to maintain that 70% utilization. So in and on the right-hand side, you've got this graph, which this is in testing. So what we had was we provisioned a capacity to 15,000 reads and writes. Now the consumed capacity was getting close to 15,000, and what you see is after roughly 5 minutes, DynamoDB automatically increases our provision capacity to maintain that 70% utilization. And again, there was a small increase in my consumed capacity. It increased the provision capacity again, the second time, to maintain that 70%. But if you look at the whole graph, I don't go above 50,000 read capacity unit or write capacity unit in this case. But now I'm getting charged for roughly 20,000 write capacity units for that period when it was at 20,000. So if you know your pattern, if you know you're not going to go above 15,000, you can change that value to say 80% or 90% utilization. So if that means DynamoDB will maintain that utilization rather than at 70%, it starts scaling. And you need to also be wary of, it takes roughly 5 to 10 minutes for it to increase that capacity, provision capacity. So at that point in time, you could potentially have a throttling impact on the database or on your application. So yeah, so make sure if you know the pattern, you can play with capacity target unit and also save cost over there. Next optimization tip is use shorter attribute names. So the way DynamoDB charges you for the storage is item size of a string. It takes the whole length of the attribute plus number of UTF-8 encoded bytes. You know that your variable or attribute value might be a different size, which you don't have a control over, but attribute names you do have a control over. So instead of having an attribute of, let's say, first name, you can have it FN for it. So you're basically saving the cost, the storage cost, by having a shorter attribute name. Another cost optimization tip is if you're on a provision capacity and you're trying to update tables multiple times, make sure, again, highly stressed, make sure you reduce your write capacity unit before you do read capacity unit. A write capacity unit are almost like 5 or 6 times more expensive than read capacity unit. And there is a limit on how many updates you can do in a day. So in 24 hours, in the first hour, you can update the table 4 times. After that, each hour you can only make 1 update to your table. So in total, you have 27 updates on a table. Now, if you breach or if you try to update table, let's say in the first hour 5 times, you'll get a message, the one I've shown on the right-hand side, that it failed to provision that capacity or decrease, in this case, to decrease the capacity because breach that 4 decreases in an hour. Now, why I highly stressed about reducing the write capacity unit was you will basically save a lot of money on reducing the write capacity unit first before you do a read capacity unit. If you do the other way around, you basically have to wait for an hour before you reduce your write capacity unit. That's another tip of how you can save on DynamoDB cost. Next tip is reduce number of non-existent items. If item does not exist in DynamoDB and you make a call, you are charged for it, whether that item exists or not. If you make a call, you will be charged. Now, one of the things you want to make sure is your application. If it gets a request saying, hey, give me this client customer ID with 1, 2, 3, 4 value, you want to make sure you checking for the patterns in your application layer. Then if it meets that pattern, then make a call to DynamoDB. If it doesn't, don't make a call, reject it, and then handle it on the application level. If you're not doing that, basically you're letting the request go to DynamoDB and items not found, it will consume the read capacity in that case. That's another tip. The item does not exist, or it doesn't, if the request doesn't match a pattern, make sure you're rejecting it or handling it on the application layer rather than letting it go to DynamoDB. Next tip is selecting between eventually consistent versus strongly consistent reads. As I mentioned earlier, strongly consistent read, so 1 read request unit or 1 read capacity unit equals to 1 strongly consistent read. And this in on demand, it will be 1 strongly consistent read. In provision capacity, it will be 1 strongly consistent read per second. So if your application doesn't need to have up-to-date data that it needs to read, you're better off using eventually consistent because that will reduce the cost. Also, strongly consistent read might have a higher latency because it needs to make sure you've got up-to-date data before it returns the value. That's another thing, not just the cost, but the performance as well. So you need to be wary of that. Next cost optimization tip is use conditional expressions for writes. Again, I go back to this whole thing of read versus write, the pricing for that. If you don't need to update the table because the item or the value exists, use conditional expression. So you are still charged for the reading because it needs to access the DynamoDB to see whether that item exists. So it will make a read call. And if that item exists, it won't write. So you're saving on the write call capacity unit. Now imagine if you got 5 secondary indexes. So if you don't need to write, but you're writing it, so you're updating the base table, you're writing to a base table, and also those 5 indexes. So basically you're consuming almost 5 write capacity units because 6. You've got your base table plus your 5 for the indexes if that data or item needs to be updated on the secondary indexes. So make sure you're using conditional expressions where appropriate. That will save you another cost over there. Next, finally, this is a big one, which we encountered quite a bit early on when we were implementing DynamoDB, is in our non-prod environment, or we've got two different accounts. We've got a non-prod account and we've got a production account. So in our non-prod account, we've got tables for different environments. So we've got SIT environment, dev, performance, then you might have SD environment. Each ones have got their own tables. So what was happening was you've got like 50 different tables with their own secondary indexes around, and half of the time no one's using those tables, and we're still paying for the data in those tables. So if you don't need those tables, delete those tables. You will save on the cost. Another thing, if the data in those tables is not sensitive, for example, in my case, we work in bank, so we've got a sensitive data. We can't copy that data over to a different region because of those restrictions. If your data is not sensitive, you can probably choose a cheaper region to host the tables. That will save you cost. Another factor to watch out in non-prod is the human factor. So quite a lot of our team members had access to our non-prod environment. So they would basically, for their testing, they would provision the capacity, run their test, and then forget to bring down the capacity. So and then suddenly we'll get a bill. Our head of would get a bill, and he would be like, that's more, we're paying more than what's in production, what's going on. So one of the things we had to do was to train people up, saying, hey, if you are provisioning, make sure you bring those provision capacity down. Another thing that we did was to put controls in place. So we set up alerts on the tables as well as on the account level. So if our provision capacity goes above certain threshold, one of myself and another team member would get an alert saying this specific table, the capacity has gone up. And then we would basically talk to the person who has increased that capacity to make sure that's meant to happen. If not, they need to bring it down, the capacity, as well as by doing that, it basically started giving that feedback loop to the team members that someone will come and ask why. We didn't want to micromanage or do anything like that, but it was more like the cost of running non-prod was getting out of hand. So we had to do something about it. Another thing that I've done is, again, you can go to my GitHub repo. I've created a Python script which you can run. You might have to modify it based on your application, but you can run this code every night as part of a batch process, which goes into the DynamoDB, looks at all the tables that are provisioned and converts them into on-demand. And that means you're not paying for extra day of provision capacity. So that's another tip that you can follow. And finally, that's it on DynamoDB. And if you got any questions or you need to contact me, those are my details, GitHub, LinkedIn, or Twitter, and you can reach out to me for anything related to DynamoDB. Thank you.
So let's take just the two questions. And the question from Scott is, did you increase the partitioning, adding a random prefix, or maybe hash the key and perform a calculation on it?
So we did add a random key. And we also, the partition key that we were using, we had to use client ID or customer ID in our case, which made it more what you call unique. So that helped us. Yeah.
So from all what you mentioned, when you go on a DynamoDB journey, you have to design and think the app to avoid any surprise in the cost, because it's pretty much, depending on the design of your app, it could significantly impact the usage of your DynamoDB app, I think. No?
Yes, that's correct. Wrong design, and you're in a bit of a pain, and big bills will come, or whoever is signing those bills might get a shock.
Sure. Scott, the question from him is also, was the use case mainly for writes in the application or a mix of reads and writes?
Mix of both read and write.
Yeah, because you do an ETL process, so I guess you first feed data and then you do some calculations, and then you re-get the data back somewhere else, I guess.
Yeah. So like in ETL, we didn't know what kind of data we had. So it might be the same records duplicated when they created the ETL files for us. So we had to do a read to make sure data exists. If it exists, don't write it. If it doesn't, then write it.
Gotcha. And I had one question. It was you mentioned that you were doing a mix of provisioning and on demand, and there was also the ability to define that you want to consume 70% and it will increase, it will scale a bit more. I guess that type of configuration will add an extra cost in the top of the between on provisioning and on demand, or is it similar? It's part of the on demand.
It's only part of the provision capacity. That's 70% utilization. So it does not apply to on demand. So on demand uses a adaptive capacity. So it looks at what was your previous peak, and based on that, it decides what would be your next peak. Whereas that 70% utilization is only specific to provision capacity.
Gotcha. So basically, from the moment you have seen or observed some spikes in the past, then the on demand will bring value for usage, I guess.
Yeah, and it's quite critical to do performance testing of these things before you deploy in production, and with the right data set, because that will give you the it will replicate what you expect in production, and you can implement those changes, this provision versus on demand in production. Right. If you don't do it, then it will be an interesting times.
So go ahead.
So like in our case, we had masked data, so we had scrambled data, but it represented what our existing production data looks like. So that gave us a really good indication what we will expect in AWS when we do the ETL job. So and based on my result, the BAU team were basically able to implement those changes, and they didn't encounter those issues.
And one last question, so then I can let Harry ask his own questions. It's you mentioned monitoring, so usually the CloudWatch monitoring depends on the layers, is pretty much a black box. So you mainly do counters. There's no much white box monitoring giving you what type of queries happening, what's happened on the database level, so sort of a mix of logging and details. Do you have that type of level of information, or it's going to be mainly a number of reads, number of connections, number of writes, things like this?
So in our case, what we have done, so you've got basically that white box, black box thing with the AWS, but in our code, we were logging what our requests were doing. So that way we can use tools like Splunk to analyze. So maybe it's the next topic sometime. It's how we've got our architecture, the way we do ETL, and we use SQS, SNS, all those things in our process. So we've got logging to find out when the request arrived, all the way into DynamoDB, how long did it take? So we were analyzing those results because we've got a strict SLAs for that ETL job to finish, and how long each item takes to write into DynamoDB.
So were your logging mechanism more useful and meaningful to take decisions compared to the type of metrics that were exposed in CloudWatch?
Yes, earlier on, yes, it helped us quite a lot improving our performance. especially when things started throttling and we're like, what's going on? We could see our whole item right was just, it's like a whole hockey stick response time, just going from slow, and big, high response time. And we could do that with the CloudWatch Insights. So we wrote our own queries because with the logs, as well as using Splunk, we were able to analyze those results.
All right, so thank you for your presentation, Harinder. Thanks for your making the time and the to build this content and take the time to present for the community. So thanks a lot, and yeah, enjoy your day.
No worries.
And please, if you can stay with us during 24 hours, that will be just amazing.
Yep, sure. And my pleasure for being on the pack this time around as well. Thanks.